So, hello everyone. My name is Mohammed Azmal. I'm the founding engineer of iMesh. And in this webinar, we'll see how to migrate from Ingress to Gateway API. And we'll be seeing it live. So, previously, we had already discussed how should the migration be going and how to carry forward. But in this session, we'll have a live demo and regarding how to demonstrate all those things. So this is going to be the agenda for today. We'll be discussing about the 3 years migration strategy, just an overview of it. And we'll also have a look at how do you map an Ingress config to a specific gateway API resource or any specific gateway API concept, which will be followed by a small demo in which we'll convert an application which uses Ingress to use gateway API. And then we'll just have a look at the benefits of migrating to the gateway API. So to begin with, this is a very brief introduction to the 3 years migration strategy that we had covered previously. So it starts with the research phase, and this is something which is done before going to direct conversion from Ingress to Gateway API. In research, we understand what is Gateway API. If our team or ourselves is not familiar with it, we understand the concepts associated with it. We understand what are the CRDs and what they do, and we analyze what is the application scope, which controller to pick up if we are shifting to Gateway API. Is the controller that you are using already supporting it, or maybe you want to switch from say Nginx to Istio or Envoy Gateway and stuff like that. And after that, we have the rollout phase. In the rollout phase, we test with a small POC. First, if we are not familiarizing ourselves with the Gateway API, we won't be going ahead and starting the conversion yet. We make small POCs for us to understand what is Gateway API and how to use it. If you've already done it and you are already confident with the implementation of Gateway API, you have the understanding of how to do it and what to do, then we first take a very small subset of our application or a specific service which is having the least load, or maybe you can say not a very major service in your application, and we convert that from Ingress to the Gateway API. And we do that by understanding, first we map what are the Gateway API resources or what are the Gateway API concepts that we are going to use depending on what is your use case that you have been following with the Ingress. And after that, we convert that small subset to use Gateway API. And then once the completion is done, right now we are not going to remove the Ingress completely, but we'll use an external load balancer. It could be an application load balancer or a custom load balancer that you have in your cluster or anything else, just to shift the traffic between both the existing Ingress and the new Gateway API. So initially we start by shifting 90% of the traffic to Ingress, and the 10% should be going through Gateway API, just so we understand that okay, if there is any error or any bugs that we are getting if we are using the Gateway API, and gradually we increase the fraction that is going to Gateway API, and slowly it is being completely adopted. And then you might have to you might choose to remove the initial load balancer and directly expose the Gateway API, or whichever way you're going to use it, you make sure that you have removed all the Ingress resources. And this is the story for the development environment. The same thing is going to be repeated in staging and prod environment, where you analyze the traffic, where you also analyze that if you're not getting any errors associated with the Gateway API and anything like that. So I said that we'll be mapping some of the Ingress config to Gateway API. So we need to understand a few of the things, at least the one that we'll be covering in this demo. So first is the Gateway CRD itself. So in Gateway API, we have the Gateway CRD. It is used to get the traffic into the cluster, and this will be used instead of Ingress. In Ingress resource, we already have probably an Ingress running, Ingress controller running in a specific namespace. Say for example, if you're using Nginx, the Nginx controller would be running inside Ingress Nginx namespace or anything where you have installed it, right? And we need to instead of using that, we'll be using our own Gateway CRD and with the respective controller. But the change here is that the Gateway CRD is not already running somewhere. Once you deploy a gateway, it will basically run in a specific namespace, or wherever you're deploying, a new pod will appear and a new service will appear, which will be mapped to a respective IP address instead of using the same IP of the controller that is running. Then we have HTTPRoute. HTTPRoute is basically used to route the incoming traffic. It is used to apply matches, filters, and other rules that are already present in Ingress. So most likely you will be using the HTTP route if you're dealing with HTTP request and all. and whatever you are achieving with Ingress is everything is possible with the HTTP route itself. One of those things is header injection, and you can use HTTP route to inject request or response header in your entire request flow before reaching the service. And it has a very declarative approach as compared to the annotation based approach we have already seen in Ingress. Similarly, we also have path-based matching, which is one of the most essential thing in routing the traffic, and it is supported by Ingress. The path spec is already there in Ingress, but we'll be using HTTP route to route the traffic. There is also an equivalent path specification here, but which is much more declarative. It allows you to do a lot many things with it. So we'll be seeing that in the demo itself. So for the demo, there are few prerequisites. As in my cluster, I already have Nginx controller and Istio Ingress configured. So I'll be using the Nginx controller for the Ingress and the Istio Ingress controller for the Gateway API side of things. We'll be deploying a very small banking application and use Ingress to route the traffic to respective services. And then we'll deploy the Gateway API CRDs, which is the gateway and the HTTP routes associated with it. We'll also see a weighted traffic distribution to the Gateway API. In the weighted traffic distribution, you may choose to use whatever load balancer. Since I'm running this locally in my system, so I'll be using HA proxy in my system to just route the traffic to both the IPs of the cluster. And this is the application diagram. We have a bank dashboard, which is acting as an interface, and it is making requests to user account and user profile services to get a few of the user information. So we'll be exposing a gateway, and this is how the client will start communicating with it. Initially, the client in the business logic is supposed to communicate with the backend, but I have also exposed the user profile service so that we have an understanding, okay, how to convert a very low, like a very low priority service at first. So we'll be using that, and we'll be exposing it through the gateway as well. And we can this will be done by both Ingress and Gateway API. In the demo, you'll be seeing that. So let's jump into the code. So, so here we have a few things. So I'll just open first is we are going to create a banking app namespace in which our applications will reside. And after that, this is the application. So we have the deployment and service associated with each profile. Each application. We have dashboard, we have dashboard service, we have something for profile service and profile deployment. This is a very simple application. There's not much in the application code itself. In the deployment, we are simply fetching whatever images we had. You can find this in Docker Hub of iMesh AI. These are public images. You can use it in your own testing environment, or you can use it to try out all these things. And the service logic is also very simple. We are simply exposing the relevant port that is there for the traffic to come in. And this is the same for all the account, dashboard, and profile and everything. So this is all about it. So let's go ahead and deploy the application first. So I'll be creating the banking app namespace. And then I'll be applying all these files to create the application. So here we can see that everything is running. We have the dashboard running, the account and profile running. Each of them have their own services, and all these things are up and running right now. So, and let's have a look at the Ingress files that we'll be using. So first, we'll be converting the profile to profile will be exposed through Ingress. And as you can see, this is just a normal Ingress resource. We have given it a name, which is Banking App Profile Ingress, and the namespace. I have some of the annotations, which is just to work in the Azure cluster that I'm using. And what I'm doing additionally here is that I'm also injecting an external header called controller Nginx. So we know that whenever a request is coming through Ingress, it is having a header like controller Nginx. The Ingress class name here is Nginx because we'll be using the Nginx controller, and the path associated with it is user's path. Whenever the request is coming to the user's path, we'll be forwarding it to the service profile, and this will give us a list of user, and all those things are there, and the port number is also defined. So let's apply the ingress file. So it is created, and for the IP, we'll basically use the controller's IP, whatever is associated with it, to reach it. And this is this IP. So we can simply do curl dash v, okay, slash users. Okay. Should give us the response in some time. And we have a similar file for the dashboard as well, in which we have given the all the informations related to it. The rules and all is there for the balancer to be applied. Let me apply this file also, so that we have both the things to test. Yeah, for some reason it is taking a bit longer. Yeah, we have the response here. And you can see that the response coming has the controller Nginx here as well. I can use the same IP in the browser as well, so that you can see that we have the dashboard also running in the root profile. The dashboard is internally making call to the accounts and user profile, all the things is there. So this is the Ingress approach. We have already used Ingress, and both the things are working here. I can show you this one as well. So we are getting the entire thing. And if I simply look at the headers, we are getting the controller Nginx. In case of root one, you can see that it's coming. A few other headers are also there because it's a Next.js app. So we have a variety of headers associated with it. And for the users one, we are also getting set of headers for user and the controller Nginx. And now we need to convert it to the gateway API. So very first thing you need to do is, we already have seen that this IP is coming from the Nginx controller, right? But in case of gateway API, you do not use the IP of the controller that is running, but it will create a new resource. So very important is that you first create the gateway resource itself. That is the gateway. So here we have created, this is the specification for a gateway. And here we are giving the name and namespace, and again the annotation, which is for Azure. And here I'm specifying the gateway class name to Istio, so that it is going to use the Istio Ingress. And all I'm doing is I'm providing a set of listeners. In this case, I'm only providing one listener, that is opening a port at 80, and the protocol is HTTP, and it is allowed to communicate. All the routes from any namespace can communicate with it. So this is the permission that we are setting. Note that this level of permission setup is not available in Ingress. You'll probably use RBAC and other advanced things to do so. But if you look into the gateway API specification itself, it provides a lot of control over your namespace, inter-namespace communication and all, even without using the RBAC. So let's apply the gateway first. Right, gateway is created. And the gateway will be created in the banking app itself, and will have the IP associated with it. Okay, the IP is pending. Let's see once again. Yeah, this is the IP. Now let's try to. Okay, right now if I do curl, we don't have any HTTP routes. It doesn't know where to route the traffic, so it will most likely time out. But now we need to convert the routing logic, what was there in the Ingress profile and the Ingress dashboard, to something using the HTTP route. One more thing you need to keep in mind while using the gateway API itself is that, so one gateway can be associated with multiple HTTP routes, which we'll be seeing right now. But in case of Ingress, it's just one controller, Nginx controller, or any controller that is being used by all the you can say the Ingress profiles, whichever is having the gateway class name as Nginx. But in case of gateway, even if you're using a specific gateway class name, as it is creating a pod of itself and running in your namespace, so you can have multiple gateways. Even if they use the same gateway class name, you can choose which gateway to use in which HTTP route. So this even makes it better if you want to use different gateways for different set of applications or in different namespaces. So this is a good thing to have. And also, if you look in the Ingress profile, I'm using the server snippet to set the headers. And ideally, it will not be allowed you'll not be allowed to do so using the Ingress resource. For that, you'll have to do some more extra configuration on the Nginx side. You need to edit the Nginx controller config map. You're supposed to enable the enable snippet option to be true. And then you have to roll out, restart the deployment. So even in the setup, you can see that there's a lot of friction if you even want to use the controller to its full potential, and you won't be getting that out of the box. Just if the controller is installed, there might be some additional configuration you need to do. But however, this is because we are using Nginx controller with the Ingress. If you would have used some other controller, maybe those shenanigans would still be there because the implementation is different from implementer vendor to vendor. But in case of Gateway API, since it is a very declarative syntax, the basic, or you can say the sub core features, is going to be supported by all the vendors provide that is supporting Gateway API. So you don't have to worry, and you don't have to do some additional configurations here and there to just make things working. So we are already seeing some of the advantages coming out if we are using this one. So let's have a look at the HTTP route profile now. And you can see the declarative syntax. I'll also open the Ingress on the other side. So in Ingress, we are setting a header and we are providing a path, we are providing a backend. Compare it with the same with the Gateway API specification. You see that we have an HTTP route. We give it a appropriate name and namespace. And in the parents refs, we are specifying that which gateway essentially you want to use. The gateway we created just now was named banking app, and since it is in the same namespace, I'm only giving its name. But had I have like more than one gateway or maybe other gateways, I could have specified something else here as the parent ref to which gateway I want this HTTP route to be associated. And you can associate one HTTP route to multiple gateways as well. And that is entirely missing here in the Ingress side of things. Same thing comes to the rules. We have a set of matches, and in this case, I'm using one path-based matching for users. And the way this is very similar to what you see in the Ingress side of things as well, but it's much more declarative in sense that I'm using specific matches and then I'm applying the filter. So whatever we were doing with the like header and server snippets here in the annotations, we are doing the same thing using the filters. And the good thing is that this filter is the property of the CRD. It is not some any random annotations that you can simply set up. This is a well documented element of the CRD itself, and this can be used for doing most of the tasks. At least in the core features also, you will find a lot of benefit of using Gateway API over anything else. So here we are using the response header modifier, and we are adding the controller Istio into the header. And then we are also providing the backend refs. Basically, this is where I specify which backend to use. And the name of the service is profile, and it is running in the same namespace. So I'm giving it a name and port. The HTTP route for dashboard is also very similar as compared to the Ingress one. Here also we'll be doing the same thing. The only thing is that I'm not providing any matchers here because by default the traffic will be routed here. That's what I want, and that's how I've kept it. Only thing is I'm adding the response headers and adding the Istio to the controller. This controller Istio is being added to the header, and I'm referencing to the respective service that is there. So once I've done this, I can simply apply that. Let me apply the route files once again. So once the HTTP routes are created, I'll make a call again to the IP, and you can see we are getting the response back. This is, by the way, the gateway response. So that's why it's giving me the HTML. Now, if I open that in my browser again, so it's opening the dashboard, and from here I can, again, the functionalities is there. And if I open users, you can see I'm getting the controller Istio also here. So this is the part where we have deployed both the Ingress and Gateway API. But the thing is, both of them are coexisting in the cluster. Right now, we need to load balance between them. And as I discussed, we are going to do that by shifting 90% of traffic to the default Ingress because that's what we were already using. and shifting only the 10% of the traffic to the gateway API. And this is why, because we want to see if any errors or anything is happening in gateway API, or is it able to handle the load or not. So in order to do that, I'm using HA proxy locally. So in the README itself, if you want to use HA proxy just to test it, that's well and good. So I've also documented what all steps you need to do. First, you need to make sure that you're having the right configuration file, and you need to modify that configuration file. So I'll open that up here. And you need to make sure that whatever IP address you have in your uh, for your whatever adapter, I'm using the wireless LAN, so I'm going to take that adapter. This is the IP address, and I'm just exposing a front end over here for port 80, and I'm having a set of backends. Now you need to make sure that these IPs are the IPs of your Ingress and Gateway API specifically. So let's just verify it. And we'll also go into the banking app. So the IP for Ingress is this one. And if we see, it's the same IP. However, the IP for the uh, banking app, whatever the gateway we have used, it might change, because so for testing, I had created a gateway. Once I remove it, that service is lost. That pod is already gone. So if you have a new one, you'll be having a new IP here. So that IP, let me put it here. Right. And once it is done, I need to also reload it. I'll reload the proxy. Yeah, now I'm good with it. So now basically whatever my IP was here in for the wireless LAN, that is now being serving me the application. So if I simply go to that IP, I should be seeing my dashboard. Okay, it's working. But now you don't know where the request is essentially ending. So for that, we have already applied the load balancer, but let's test it out as well. So you can simply run. So I'm using curl in this case, and what I'll be doing, I'll be making 10 requests, and I'll simply grab what was the header. This is why I added the header initially, even in the demo, so that we can test if the load balancing is working or not. All I need to do is I need to put my IP here correctly. Oops, forgot I copied it. And we'll wait for some time. Just for the sake of this example, I'll reduce the sequence from 100 to 10. Okay, so approximately 9 requests went to the through the Nginx route, or the Ingress route, because we are checking for the Nginx header name, header value, and the same thing we can do for Istio as well. And only one request is going there. So you can, however, change the percentage. For me, I'm running it locally. I can again just edit the configuration, change the weight accordingly, and then it should be working for me. You can choose whatever load balancer you want for this thing. I'm using HA proxy in this case, so not necessarily you need to use that, but anything would work. Basically, even if something is there in your Kubernetes cluster, you might use an existing Ingress gateway also to route the traffic, or existing gateway API gateway APIs, you can say gateway to route the traffic in between them. Anything that basically routes the traffic, so that you are not transferring the entire 100% request directly to gateway API in the beginning, because there might be chances that it might if you have not implemented it correctly, or something is failing. So it is always good to have this thing done here, and this is one of the most vital part in our 3R strategy as well, that you always load balance first. You test whether the gateway API is performing well or not, and then you move ahead and completely adopt it. So this was the demo side of things, and definitely few of the benefits we already saw in terms of why we should be using Gateway API. First of all, it is very role oriented. We saw that we used Ingress to just route the traffic in to both the services. In this case, we are using Gateway and HTTP route in combination, because Gateway is solving one purpose and the HTTP route is solving the other. So you won't be using the same CRDs over and over again, which might cause issues, that something might be overwritten here and there. That has been properly taken care of. Even it is very much suitable for RBAC. With RBAC policies also you can use this, but even if without RBAC, it is like it is providing a lot of features, lot of like namespace level controls and all those things which you can use. It is portable. We saw that we already used Istio, and in the Nginx Ingress controller, whatever we were using, the Ingress was using something like server snippets and other annotations that are specific to Nginx controller, and this might vary from vendor to vendor, but that's not the case in case of Gateway API. So if I just want to use something else or some other controller that is supporting Gateway API, all I need to do is I need to go to my configuration in the gateway, and I need to change the gateway class name, and that's all. I can also use multiple vendors. So say for example, in this gateway I'm using Istio. I could simply create another gateway that would use maybe Envoy gateway, and I will just attach that gateway to this parents ref of any of the HTTP routes I want. So you can already see the flexibility that you will be getting if you are using Gateway API and all the things you can do with it. And comparing both the configuration, we saw that it is much more expressive in nature. It supports almost all the core functionalities of Ingress, whatever we had, header based matching, traffic weighing, all those things is also possible. And we just saw that header injection is also possible with it. So this is one thing we have already covered. It's much more expressive in nature, and it is extensible as well. So right now we are routing traffic internally in our own services, but you might however choose to use some external filters. Maybe you have some webhooks you can use with filters. You want to route the traffic to some third party IP, you can even do that in backend refs in much more declarative fashion. Doing the same with Ingress is oftentimes pretty tough, and it requires some, if you are doing something out of the box or something very much not into the traditional traffic management thing, you'll have to play with the annotations a lot. And server snippet is going to be very you can say very error prone in these scenarios. But in case of HTTP route and in case of gateway API's specification itself, the CRDs have a very good extensibility, and they're going to be very extensible. So this was all about the demo, and if any questions are there, I'll be happy to take. And this is a very lightweight example that we have covered so far. If you need anything much more accustomed, anything advanced, if you want support on, if you want to convert your own application to adapt the new gateway API, definitely reach out to us. We'll be more than happy to help. And if you have any questions, I'll be happy to take.